So this chapter is about the way we use mental images and the way we use them to basically to think and to solve problems. It's important because we are a visual species. We are a species that is basically our primary sense is visual. Um, so for us, it's an important thing. If we were talking about rats or dogs, we would probably be talking about representations of smells and cognition because they use smells to navigate, but we use primarily vision to navigate our world. Um, One of the things that mental imagery has historically been good for is for memorizing things, being able to remember. So images make a good mnemonic device. That, in other words, they make a good way for you to help you remember things. Essentially, what images are, by definition, is that they are mental recreations of sensory information that you've experienced in the outside world. The image can consist of all of the senses, not just visual, but also auditory for hearing, olfactory for smell, and tactile for feeling. So, for example, if I were to ask you to, imagine running your hand over a piece of velvet, red velvet, right? So you see your hand running over the piece of red velvet. And not only will you see the red velvet, but you can also imagine the way it would feel as as you're running your fingers across it. Um, One of the really neat things about mental images is that you can create them even without having actually experienced a particular event. So, for example, I can ask you to, imagine yourself at ground zero during 9/11 in lower Manhattan on September the 11th, 2001. Now, most of you, none of you were probably there when when the Twin Towers fell, but you could put yourself into that situation, and you've seen enough news reports and enough movies and other things that you can probably conjure up a pretty good representation of what that would look like. So one of the big debates about mental imagery is essentially spatial representations versus propositional representation. So, what a spatial representation is, it's described in your book as being an analog representation. I have no idea what that means. I don't know why they use that term. Well, it's used in the literature, but it's not a good term. But basically, what spatial means is that we represent the things, images in our minds, much the same way that we experience them when we see them. So, for example, if I ask you to uh, build a represent, to get in your mind's eye an image of your car, the car that you drive, and then I ask you to walk around your car and walk from the front to the back. Um, you're going to be doing that in very much the same way that you would as if you were actually in front of your car. So the representation in your mind is going to be very much like the representation that's formed when you're actually looking at your car. If I were to ask you to mentally go from front to back, it would take you about as long to go from front to back as it would take you in real life to walk from the front of the back of your car. Um, so in this way, the meaning of analog means that we sort of hold the same type of representation in our minds that we experience when we're actually looking at the actual things. This sort of idea is much more strongly supported than the alternative, which is a propositional representation. A propositional representation is very different from a spatial representation. A propositional representation is made up of, well, propositions. Propositions are statements about a certain object. They are statements that describe a certain object. So instead of having like this actual like mental image of, say, your car, that you sort of rotate around and walk around, and that it's represented in much the same way as it is if you're standing in front of it. What a propositional representation is, it's a series of descriptions, language descriptions of the thing that you're experiencing. And we store that, we store representations as propositions, as a set of rules that help us to render a particular image. In this, if you're a propositional representation believer, one of the things that you think is that, or that you believe, is that the imagery that you see is just a side effect of the execution of these rules, these propositions that are describing what it is that you're seeing. So here's an example of spatial representations from your textbook. The participants were asked to create images of objects they had seen, like, for example, an airplane or a lighthouse, and then focus on a specific part of the object. And then they were asked questions about another. So they were asked to focus on one part of the object, but ask questions about the other, some other part. Um, the further away the parts were from each other, in other words, the part that I asked you to focus on versus the part that I asked you about, the longer it took to answer the question, which basically we believe is because of the fact that it takes you longer to walk over there in your mind and take a look. Spatial representations also have been studied using mental maps. Like, for example, this map of an island. If I were to show people this map of an island and ask them to mentally travel this fictional island to different locations, it takes longer for you to mentally travel to places that are farther apart from each other. Which again supports the idea that we are literally sort of manipulating these mental objects, mental pictures in our heads, instead of having these propositions, these rules that are executing themselves. So here we have a spatial representation of a sentence. The boy flew his kite. Um, the boy flew his kite is an actual like propositional statement. And you can take that propositional statement and store it. And then if we render it, we can render it into this sort of spatial representation. Um, Again, there's more evidence for this idea that we do store things spatially versus propositionally. And pretty much anytime you see these battles in science between one point of view and another point of view, the truth is always in the middle somewhere. So it's probably going to be that we probably use both spatial and propositional representations to store images. It just depends on the who, what, when, where, and why, basically, so which we're still trying to figure out. One of the interesting things about imagery is this notion of the picture superiority effect. Um, it's known that pictures are better remembered than words. Words that are more easily imagined are better remembered. So a word that you can visualize easier is easier to remember. And sentences that create bizarre, weird images are better remembered than sentences that invoke just regular common images. So this picture superiority effect tells us that, again, in our, in human cognition, images work really well as memory aids to assist us in the encoding and retrieval of memory. The result, for example, Pivio studies in '91 showed that memory for pictures is superior to memory for words of the same concepts. So one of the explanations for the picture superiority effect is this idea of a dual coding theory, or dual encoding theory, it's sometimes called. Uh, and basically, what that is that pictures are able to produce encoding when you're looking at a picture and encoding it into your memory. It actually encodes information in two modes: visual and verbal. So when you're looking at a picture, not only are you encoding like the colors and the people that you see and the scenery and whatnot, but you're also encoding a verbal description, a mental verbal description of what you're seeing. This is in contrast to just words. Words, when you're reading them, words really are just one channel. You're basically just encoding words. So the fact that you're encoding an image and words that match each other leads to better encoding and better retrieval of whatever it is you happen to be encoding. And this is why uh, things like mnemonics that help you to remember things that are based on imagery work really well. The concreteness effect is a result that shows that memory for concrete concepts is much superior to memory for abstract concepts. So, if I were to ask you to memorize things about, theoretical computer science, and I asked you to memorize some things about um, uh, some concepts from theoretical computer science versus some concepts related to, say, cooking, right? You'd probably have a much easier time remembering and talking about the cooking concepts versus the concepts from theoretical computer science, because to you, the cooking is a much more concrete thing. You're doing things, you're working with different ingredients, and you're mixing things together. Versus with theoretical computer science, it's all abstract, and a lot of it is anyway. And you would have a much harder time dealing with that. The bizarreness effect is just what it says. Any information that evokes an unusual image is better remembered than information that evokes typical images. And one of the reasons for the bizarreness effect is because it stands out relative to the other things that you're talking about. The bizarreness effect is illustrated here uh, on this slide here. So, for example, the image the groups here, group 1, 2, and 3, are different um, based on the bizarreness, going from group 1, which is kind of like lame, not bizarre, to group 3, which is really bizarre. So, for example, in group 1, it says the plumber lifted the mop out of the bucket, the teacher sorted the homework in his file, the maid spilled ammonia on the table, the gardener unloaded the mulch from the truck, and the reporter interviewed the senator at the charity event. Compare that to group 3. The plumber juggled the mop out of the bucket, the teacher burned the homework in his file, the maid licked ammonia on the table, the gardener ate the mulch from the truck, and the reporter painted the senator at the charity event. If I were to ask you to look at group 1 versus group 3, if I were to ask one group of you to look at group 1 for like a minute and then repeat back the sentences versus group 3 for a minute and repeat back the sentences, most of you, the ones in group 3, would probably do a lot better, be able to repeat more sentences correctly than the ones in group 1. So a couple of mnemonic techniques that are based on imagery include the method of loci and the peg word mnemonic. So the method of loci relies on images of the objects that you want to remember, that you put in familiar locations along a known route. So, for example, if you wanted to remember to buy some cat food, pick up your dry cleaning from the laundry, and pay a bill. Go pay a bill. One of the things that you might do is visualize your apartment. So the living room in your apartment, and in that living room in your apartment, you would have a picture of your cat sitting in front of an empty bowl, some dry cleaning draped over the couch, and a stack of bills sitting on the table next to the couch. Those three things would help you to remember to buy the cat food, pick up the dry cleaning, and pay the bills. The peg word mnemonic is a memory aid, where the words that you're trying to remember are rhymed with peg words to create images of the peg words and the to be remembered items uh, that they're interacting with. So here's an example of a simple peg word technique. If you're trying to remember the words bun, shoe, and tree, um, you would combine them with the placeholder words one, two, and three. So one bun, two shoe, three tree. Um, these placeholder words are going to be a list of words. Usually, it's a list of numbers or something that's easy for you to like run through. A list that's easy for you to run through, and then you just associate one with the other. So imagery can also hurt memory in some cases. You can actually have false memories. So, for example, if you're asked to imagine an event that never occurred, this can actually create a false memory for the event as if it had actually happened. Elizabeth Loftus is very famous in psychology for doing a lot of research in this area. Uh, and found that people, if you question people about events that didn't really happen, if you keep questioning them, they will start imagining those events, and then they will start thinking that, yeah, they did happen. You see this a lot with people that are being questioned by the police. They'll start twisting around, and the police actually know how to manipulate people to get them to, to falsely confess to things because of this ability to sort of create these false memories based on imagery. So most studies have told us that imagery can help in memory retrieval, but it can also create memory errors that could be damaging if you're asked to imagine a negative event like a crime, for example. Um, this is the main reason, and Elizabeth Loftus's research was really big in this. This is the main reason why eyewitness testimony is no longer, uh, valid in most courts. Um, it used to be back in the day, a long time ago, back even up, I guess, up to the 70s. That eyewitness testimony was like ironclad. If somebody said they saw you do something, then that was a huge, huge thing that the prosecutors would use. But nowadays, we most judges, most courts don't allow somebody to be convicted just on eyewitness testimony because it's so unreliable. People can convince themselves or be convinced that they pretty much saw whatever it is you want them to see. So, one of the things, of course, that we use imagery for is for problem solving. Um, so, for example, if I were to ask you, or when you're playing cards, if you're playing, Texas Hold'em or some sort of poker, or one of the things that you're imagining are the probabilities of getting certain cards with the next draw. So if you're playing, Texas Hold'em, and you see the cards that you have, and you see the cards that your opponents have, and you're thinking, okay, well, I see a lot of queens on the table, so I'm probably not going to get a queen, right? So you're using that imagery to imagine what you're seeing. Reasoning, we use reasoning a lot in our solving problems. Pretty much no matter what it is that we're reasoning about, whether it's trying to solve like a canned homework problem, or whether you're trying to deal with a family situation, we do use a lot of imagery in solving our complex problems. The research shows that creating images in your mind can greatly aid in the solution of problems. This is a very simple example here on this slide that shows that if the gear that's on the right is turned clockwise, so if you turn that gear on the right clockwise, what direction will the gear on the left turn? Unless you're a mechanical engineer that just knows this immediately without even thinking about it, you're going to have to put these gears in your head and turn the one gear on the right clockwise, right? And then you're going to say, okay, well, what direction is the other gear going to go? And of course, it's going to go counterclockwise. Here's another example. So if the rope on the right is pulled, will the wheel on the top left move clockwise or counterclockwise? And again, you have to go through this, right? So you pull the rope and that turns the first wheel on the right clockwise. The wheel down at the bottom goes counterclockwise, and then the wheel up at the top is going to be going, I guess, also counterclockwise as it pulls and lifts up the weight that's there at the bottom. But again, this is something that you're going to be going through, and you're going to be pulling the rope and watching the little wheels turn in your head. Again, unless you're like a like a like a mechanical engineer or somebody who does this for a living. I don't know who would do this for a living, but somebody does probably. Unless you just know this instinctively and have done it again and again and again, you're going to be actually going through the imagery of rotating the wheels to see which way they go. So Hegarty's 92 study gave us some more evidence that we actually do use, this sort of analog imagery when we're trying to solve a problem like the pulley problem that we saw in the previous slide. Basically, what this slide is telling you is the further away the pulley is from the beginning of the rope, or the part of the rope that's pulled, the longer it takes you to figure it out. Because what you're doing, what most people are doing, is following the rope, starting with the beginning of the pull and following that rope and going from first gear to the second gear to the third gear, or the first pulley to the second pulley to the third pulley. And the longer it takes you to wander, or the further away the pulley is from the start of the rope, the longer it takes you to respond to the question, what direction is pulley number 3, say, for example, rotating, versus what direction is pulley number 1 rotating. We also use imagery in wayfinding. Trying to find our way across, across campus or across a city or whatever. There's two types of wayfinding that are useful: scenographic imagery and abstract imagery. Scenographic imagery is what you see when you're walking through the environment. So I have to travel a lot when I for my job, for my day job, and one of the things I do is whenever I'm in a different city, and if I walk from one point to another point, one of the things that I do is I try to make note of the things that I see along the way. So I'm like, oh, there's a store that sells pastries. There's an ATM machine. Oh, here's a train stop. And I use those points, those waypoints, as a way back. So if I'm walking back to my hotel or whatever, I'm like, oh, okay, I remember I saw that ATM machine when I was walking over here. I pretty much know where I'm going. And a lot of people will give you directions, using scenographic images. So, turn right at the Bolero station, turn left where you see the big tree, whatever. Abstract imagery is where you have a map-like overview of the environment. So it's where you're holding a map-like image, so you know in space where things are without actually seeing them. So you have like this map-like image. People that can use both of these types of navigation are really good at navigating. You all probably know somebody who's terrible at navigating, who doesn't, who is unable to do it. And the reason they're probably not very good at it is because they don't have this abstract imagery. They don't have a representation of what's out there, um, in whatever particular environment they find themselves. Abstract imagery is much more helpful in navigating. If you know where things are, you know where the buildings and you know where your destination is. You know the roads that'll get you there. It's much more helpful in navigating a particular environment. So, here's an example of, imagery versus, an abstract images. So we have these, different views inside of a building. This looks like a university building somewhere, right? I guess the author's building. So we have, we have the men's room, and we have, the door going out. Over here we have, down in the basement, we have a hallway here, right? So, these are just navigation points that you would see versus this, which is a map of the entire floor. If you can have this map in your head, you're probably going to be doing a lot better in finding rooms than sort of navigating these little waypoints that you see along the way. Um, Motor imagery. So, in other words, the movement, the imagination of movement. It's a mental representation of motor movements. One of the things that we know is that research shows us that imagining yourself doing a certain complex motor movement, like, for example, shooting a free throw or hitting a golf ball, helps in performance. It's not the only thing. You have to actually do it, but it does help in performance. Um, Imagery can also help with simulation. One of the things that, for example, imagine yourself in a job interview. Um, Imagine yourself going to a job interview, going to the office, talking to the front desk person, uh, and then from there, getting taken to the interview room and then meeting the first set of interviewers. That sort of imagery helps a lot in dealing with social interactions, for example, like with job interviews. Um,